Okay, guys, welcome back to 2-7. We're going to be solving proportions. All right. A proportion, as we learned last section, is an equation that states that two ratios are equal. Okay, for example, this is a proportion. A to B equals C to D. That is a proportion. Okay, two equal ratios. Equal ratios. Where B and D are not equal to 0. Why is it important that B and D are not equal to 0? Sir. Because then they would be undefined. Very good, son. Very good. Now, you read this as A is to B as C is to D. Because basically you're saying that the ratio of A to B is equal to the ratio of C to D. So it's read as A is to B as C is to D. Okay? When we're setting up proportions, you must always remember these two guys must have the same units, and these two guys must have the same units. We'll talk about why that's important in a little bit. Okay, now, you can solve proportions by cross-multiplying and solving for the missing variable. That is the beauty of proportions. So easy to solve. You just cross-multiply and solve for x. And we're going to do examples of this, but I just first wanted to give you the verbiage, the actual procedures, bless you. And then from there we'll work. You can also check to see, gentlemen, if two ratios are proportional. Also by cross-multiplying and comparing the cross products. If the cross products are the same, then they are proportional. If not, then they are not proportional. Are the following ratios proportional? Well, we're going to cross-multiply and we're going to compare the cross products. So 35 times 2 is going to be 70, and 5 times 14 is going to be 70. So the cross products are 70 and 70. Are they equal cross products? So is this a proportion? Yes. Does that make sense, guys? So if I give you two ratios and I say, are they proportional? All we got to do is cross multiply and compare the cross products. Those cross products are equal, and giddy up. They're proportional. If the cross products are not equal, then they are not proportional. Does that make sense, gentlemen? Okay. Let us continue, please. Now, we also said that you can solve proportions by cross multiplication, by cross multiplying, and it is that easy. What is the solution of the proportion blank? They're telling you already that it's a proportion, so you know that they are proportional. So therefore, let's go ahead and cross multiply. Okay, when we cross multiply, you go from the denominator to numerator, right to left, and then denominator to numerator, left to right. So you have 8m equals 84. I want to solve for m by dividing. I'm dividing because I'm canceling out multiplication. So I divide 8 to both sides, and m will equal 10.5. You are done. I promise. It's that easy. Yes, sir. I divided, sir. Okay, the question is, how did I get 10.5? Okay, this, guys, I don't know what to tell you anymore. You're not in middle school. You need to know how to divide. So 8 goes into 84 one time, carries the 4. 8 goes into 4 0 times. Decimal, bring down the 0. 8 goes into 40 5 times, 10.5. What don't you understand, sir? Sir? Thank you, sir. Okay? It's a matter of just simple division. Now, you may ask, how did you do that in your head, though? This was a very easy one. Think about it. How many times, my brothers, does 8 go into 80? 10 times. What am I left with? I just created a mixed number, didn't I? Isn't that 10 and 1/2, which equals 10.5? I'm not a genius. Not even close. I just know my simple basic math, guys. Got to be able to know how to divide and how to go from an improper fraction to a mixed number quickly and efficiently to help yourselves. Number 3, what is the solution of the proportion blank? X over 7 equals 4/5. Cross multiply. So this is 5x equals 28. 5 divided by 5 because I'm canceling out the multiplication of 5. And x is going to equal 5 3/5, which equals 5.6. How did I get that? 5 goes into 28 5 times, and there's 3 left over, which equals 5.6. How did I get 0.6? 3/5 equals 0.6. It was something that I told you guys to memorize. If you didn't memorize it, you convert a fraction to a decimal, like we have done 100 times already, by dividing. 5 goes into 30 6 times, so my answer would be 0.6. So all sorts of different ways of how I got this answer, gentlemen. Sir, you are allowed to leave it as a mixed number unless I specifically ask for it, sir. Thank you, my brother. Because in the end, if I don't ask for it, is 5 3/5 equal to 5.6? Yes, absolutely, guys. Don't get stressed with that. Unless I tell you, I want it all in mixed number or I want it all in decimal, unless I specifically tell you, there's no way I can mark this wrong if you put 5 3/5 or if you put 5.6. Okay, because they're both equal. Does that make sense? Thank you. Hey, let's continue. Let's cross multiply. X times 4 is 4x. 3 times 8 equals 24. Divide by 4. X equals 6. Done. Does that make sense, gentlemen? Okay. Now, the good ones. Sometimes you're going to have it a little bit more complicated. No big deal. Same procedure, I promise. We're going to cross multiply. But this time when we cross multiply, guys, what property are we going to be using? Thank you. That was awesome. Great job, guys. Great job. So this is going to be 4 times b minus 8 equals 5 times b plus 3. Distribute. 4b minus 32 equals 5b plus, that looks like a 6, I apologize. 5b plus 15. Now it's just Mickey Mouse equation. Minus 4b to both sides. Get the b alone by canceling out addition with subtraction. Subtract 15 to both sides. And negative 47 equals b. Simple, simple, simple. If you know how to solve equations and you understand the distributive property. Does that make sense to everybody? Awesome. Give you a couple seconds to write that down. And then we're going to do the word problems, and then we're done. And then what I'm going to do is I'm going to bring you up to the board, and then we'll do some practice problems together. Okay? Thank you. Does everyone understand what we're doing so far? All right. Now, okay, when you model a real-world situation with a proportion, you must write the proportions so that the numerators have the same units. Remember, we talked about that already. and the denominators have the same units. For example, suppose you travel 100 miles in 2 hours at a constant speed. You write a proportion to find the number of miles you will travel in 5 hours. Look at what I did here. First of all, there's a couple pieces to this. They gave you a fact. The fact was that you traveled 100 miles in 2 hours. So I always put my fact first. That's what you have to do. And I call this the fact ratio. Whenever they give you a word problem, you're going to have a fact ratio. You're going to have a fact that they give you. Okay? They're going to give it to you. Always. Now, part 2, that's where you go unit to unit. The fact is that there's 100 miles in 2 hours. Okay? I traveled 100 miles in 2 hours. I want to know how many miles will I travel in 5 hours. Check it out. Miles to miles. X miles, because we don't know how many miles. Hours to hours. Do not jumble those up. If you don't go unit to unit, you will get the wrong answer 99.9 times. Maybe you'll get lucky 0.1 time. But odds are you're going to get it wrong always because you set it up incorrectly. It's got to go unit to unit after I have already set up my fact ratio. And the fact ratio will always be given to you. We cool? All right. Portable media player has 2 gigabytes of storage and can hold about 500 songs. A similar but larger media player has 80 gigabytes of storage. About how many songs can the larger media player hold? What is my fact ratio? 2 gigs can hold 500 songs. Does everyone see how and why that's the fact? Now I got to go unit to unit. So tell me, what do I plug in here? 80 gigs, very good. Unit to unit over X songs. Unit to unit. Now, it's Mickey Mouse time. Cross multiply. So I'm going to have 2x equals 40,000 divided by 2x equals 20,000 songs. You got to put the units here. If not, you get it wrong. If you put 20,000, and just alone 20,000, 20,000 what? Gigs or songs? You guys got to tell me specifically. But this is nothing new. We have been talking about placing units since day one, correct? So this is nothing new. Does that make sense, my brothers? Awesome. We're going to have one more example, and then we'll hit the board and we'll do a bunch of, you guys will do a bunch of examples together. Sir? Oh, I'm sorry, I thought you had a question, my man. We're good? Okay. Example 7. An 8-ounce can of orange juice contains about 97 milligrams of vitamin C. About how many milligrams of vitamin C are there in a 12-ounce can of orange juice? What is the fact? 8 ounces over 97 milligrams. That's the fact. How do I set up the rest of this proportion to see what I'm solving for? 12 ounces unit to unit over X milligrams. Unit to unit. Does that make sense, gentlemen? Okay. So I'm going to cross multiply. When I cross multiply, I get 8x equals 97 times 12. So 97 times 12. 7, 9. 4, 6, 1, 1,164. So 8x equals 1,164. Divide by 8. X equals 8 on the outside, 1164 on the inside. 1 time, that's 36. 2, come on, Moro. It's not 2 times, fool. That's 4 times 32. And then you got 44, which is going to go in 5 times, which is 40. And then decimal, decimal, and that's going to go in 5 times as well. So 145.5 milligrams of vitamin C. Does everyone see what I did there? Did everyone see the math? Look at the way I divide, guys. It's pretty organized. I use arrows. I put my placement very neatly. I really try to organize myself because division is about organization. That's all it is. Okay? If you guys try to jumble it all up, you try to speed through it too quickly, it ends up hurting you. Does that make sense, gentlemen? All right, my brothers. God bless you. That's the lesson. Let's go practice now.